Okay, let's continue. Let's take the next figure. Sector of circle. Ympyrän sektori in Finnish. Ympyrä is circle and sektori is sector. So here you again see this Finnish way to add the I letter to the end of the word, sektori. So it means that we have circle and then we have a part of it like this. And this is called sektori. So the area of this kind of figure or sector of circle, it is quite easy to understand the formula for that. I think in this formula book it is written in many forms, but I think this is most easy to understand this formula, because there is the formula of the area for the circle here, pi r squared. And this a divided by 360 degrees, it tells that we are counting how big part of the whole circle we are having. If we have the degree of alpha here, and the whole circle would be 360 degrees. So this tells how big proportion of the whole circle we are having there. So this only takes account the value of the alpha here. So the area would be alpha divided by 360 degrees times area of the circle.
The proportion of the circle.
Yeah. If it would be a half circle, the angle alpha would be 180 degrees. So there would be 180 divided 360, so it gives half. Then another figure still concerning the or depending on the area of circle is the segment of circle. Can you guess what is the translation of the word segment in Finnish? Segmentti. Only you put I letter, or actually you put two T's there, so it is segmentti. Ympyrän segmentti. Well, this I will write this formula. You find it from the Moodle, from those formula pages there, or if you have some table book or mathematical handbook of mathematics, you find this formula there. But it is actually quite easy to derive from this area. And let's draw the segment of circle first. So if we are having, let's draw again the sector there, and then we cut it in two pieces over here, and this part here is called segment. So this formula, which I write soon there, it can be quite easily derived from the area of the sector. This is this part here, and if you subtract or take away the area of this triangle here, then you get this part, which is colored in red color in my picture. So this formula in this book, it is written there. These are some formulas which you need in some assignments, and I don't remember, maybe it was the 5th assignment. There you need this formula. So actually, if you multiply the brackets away, so this part here, when these will be multiplied together, this will give the area of sector. It is quite easy to see that you have alpha there, pi r squared, and 2 times 180 is 360. So this part gives this formula here. And this times this sine alpha is the area of triangle where you have two sides. These are both radius, so they are r's, and between them there is an angle alpha. So we have this sine formula for area for triangle is half of the side times sine of the angle between those sides. And here we have this sine, and r times r is r squared, and this dividing by 2, it is the same as multiplying by half. So this is quite easy if you don't remember, and I have to say that I wouldn't remember this formula just by that. I mostly take it from my formula book, or then I derive it myself with the help of sector and triangle. So I think those were the most common area formulas. There are also, for example, in this book, there are, for example, ellipse, and there are some parabola formulas there, and also in this other formula book there are many kinds of formulas. For example, regular polygon, but I'm not going through those because they are not very often useful, or they are quite easy to derive. You don't necessarily need those formulas. But let's take the formulas for volumes. volume in Finnish tilavuus. This tila in Finnish, it means some kind of space around you. For example, this glass, you may call it the tila, the place where we are studying this glass. And tilavuus means the volume, the amount of the measure of amount around the midpoint. If we somehow try to translate that to Finnish or English. Ball or sphere. In Finnish, pallo. Do you remember the formula? How did it continue? Pi r cubic. Yeah. Yes. Sometimes also the area of sphere is important. It means if you want to paint the ball outside, so what is the area of the surface of the ball? It is, I think, more easy to remember than this volume formula. If you remember the area of if you remember the area for the formula for the area of the circle, it's pi r squared, and then you multiply it by 4. Actually, have you studied differential calculus in early studies? Yes. Yeah, 500 years ago. I will show, you don't need to remember those rules, but I will show with my calculator, because when I take 4, it is a shortened form of differentiaali ja integraali laskenta. I think you may have that kind of course in your schedule in maybe next year. I'm not sure. Differential and integral calculus. And for example, here we have this derivative, and this actually you don't have to notice, but I'm counting the derivative of this formula for volume. So I will write there 403 times pi times r cubic. So now I am taking the derivative of this formula, and I press enter. It gives 4 pi r squared. So this is actually the formula for the area of the circle. Let's take an example. If we know r, it is 1.256 meters, and we need to find out what is the volume of the. So this is easy one. So we know the R, so we just use that formula. I will go through this quickly because I didn't mean to put this kind of example here. Sorry. During my sentence, I forgot what I was going to do. Let's calculate the value of this. Well, actually, let's do some unit conversions now. If we have cubic meters or meter to the raised to the power 3, how do we change this to the unit of cubic decimeters? Yes, multiply by 1000. So exponent here is 3, so we will move the point 3 steps, which is the same as multiplying by 1000. So it will be etc. Ja niin edelleen. Infinish. E. Etc. Ja niin edelleen. It would be translated somehow like and so again and so yeah. But then let's take another where we know the volume. It is 5.23 and we want to calculate the radius. What do we do first? Yes, R, we will solve the R, yeah. And what first? Well, of course, it depends how do you want to solve this, but if we want to get rid of this 3 here in the right hand side, so we multiply with it. So we get 3v equals 4 pi r cubic. Yeah, and now we lost my pen. I don't know where is it. Let's take another color. Divide by 4 pi. So it will be 3v divided by 4 pi equals r cubic. So now we don't take the square root but cubic root of this sentence. So r will be third root of this expression. By the way, some calculators do have the special button for cubic root. For example, in this button, I don't remember see if there is actually cubic root, but there is universal root button there. There is root sign, and I think it is Y letter inside of this root, and X is the index or order of the root. But many times it is more easy that to use the exponent method. For example, if we had to calculate the cubic root of some number, it is the same as raising to the exponent 1/3. So I will put it like this. I will have here exponent 1/3. For example, in this calculator, I many times do so that I calculate first this value inside of the value of the number inside the root sign, and then I raise it to the exponent or power 1/3. It is many times quicker and more easy way to get that root. But of course, if you find that cubic root from your calculator or phone, then use that. And this will be meters. I suggest you to try to calculate also with your own calculator or phone these exercises, so you get used to how to use that calculator to find out the results. And now this is a little bit over 1 meter, the length of the radius. And in this exercise we had volume given in three figures, 5, 2, 3. So there's 3 figures. So in this case, 3 figures would be 1, 0, 7, and this 7 raises to the 8. So it would be 1.8 meters in 3 significant figures or numbers. Okay, I think this is enough for today. I will continue. I don't remember if we have. Do we have a Friday or when will we meet again? There are some changes in the.
Yes, this week somehow weird.
Yeah.
Yeah, Friday.
Is it Friday?
In the afternoon from 12:15 to 15.
Okay. Yes. So we will meet on Friday. Thank you for today's lesson.
Thank you.